What's up, friends? In today's video, we're going to look over some exam questions about redox reactions. If you would like to go through all the concepts you will need about redox reactions and electrolysis instead, you can click the link below to watch that video. I'll also leave another link down below for the questions that we will use today so you can follow along if you would like. So let's go! Heads up! The questions I will be using in this video are just parts of questions. They love mixing redox questions with other topics, don't ask me why. But yeah, to the question. For the sake of time, I will only do the redox questions for this video. If you would like to go through the other questions, let me know down in the comment below. A teacher prepares the insoluble salt lead-2 bromide, PbBr2, by mixing solutions of lead-2 nitrate and sodium bromide. I'm gonna skip parts A and B as they're not redox related, and we'll go to part C. The teacher heats the lead-2 bromide. When the lead-2 bromide is molten, the lamp lights and the bromide forms in the positive electrode. Part 1. State what observation would be made at the positive electrode. 1 mark. Sometimes we need to figure out the whole electrolysis process before we can answer this question. But luckily, in this case, we just have to pay attention to the sentence given earlier. It says here, bromine forms at the positive electrode. In other words, we just need to state what does bromine literally look like when it forms. And the answer to that is a brown gas. You could also state an orange gas. That's also okay. Done. Next! Question 2. Part 2. Explain how bromide ions in the molten lead-2 bromide become bromine molecules at the positive electrode. 4 marks. For this question, they want us to focus on just the positive electrode, aka the anode. If we recall, the anode is where oxidation occurs. Think about anox. Oxidation is about losing electrons. Remember oil rig? On top of that, bromide ions will turn into bromine, thanks to the conformation of the previous question. Bromide ions will lose electrons to become the bromine molecule. We can even answer this question by writing the half-ionic equation. But I digress. To formally answer this question and to score the marks, we have to spell everything out. First, bromide ions are negatively charged, or are anions if you're feeling fancy. Then we have to state that they will be attracted to the anode, the positive electrode. And at the anode, the bromide ions will lose electrons or get oxidized to become the bromine molecule. And this is where you can also write the half-ionic equation, like so. That last point is actually worth 2 marks. And that's part 2 done. Part D. Write an ionic half equation for the reaction that occurs at the negative electrode. Include state symbols in your equation. 2 marks. In this question, we're looking at the cathode, where this time lead-2 ions go to. To answer this question, we need to think about what the aqueous lead-2 ions form. And the answer to that is solid lead, which is written as Pb, like any other metal element. Don't forget to add the state symbols because this question explicitly stated it. From there, we need to check the particle number at the bottom right of both the ion and the element. Here, both are blank, so they've already balanced out the particle number. So the only thing left to do is balance out the charge with the electrons. On the left side, there's a +2 charge on the lead-2 ion. On the right, there's no charge. So to balance out the charge, we need to put a -2 on the left side to give it an overall charge of 0. This means that we need to put 2 electrons on the left. Just FYI, you get 1 mark for writing the correct formulae and balancing the equation correctly, and the other mark will go to using the correct state symbols. And that's a job well done. Quick word before we go, can I ask you a favor? If you found this video useful, can I ask you to subscribe to the channel and or like this video? It would help the channel grow, and in return, I will make sure that the bigger the channel gets, the better the content gets. Thank you for watching, and I hope to see you in the next video. Bye!